Okay, I think we're going to get things started here then. So let me start from the top here. For those of you that have just joined us here, I just want to welcome you to this special webinar on the advantages of soft start motor control, sponsored by Eaton. My name is Miles Budimer. I'm the senior editor for motion control here at Design World Magazine, also at motioncontroltips.com and linearmotiontips.com. And I will be the moderator for today's webinar. Before we start the webinar, a few points of order here. So this webinar will be available afterwards at designworldonline.com, and each of you that are here will also get a copy of the presentation via email. We encourage you to submit questions throughout this presentation, throughout the webinar, and at the end of the presentation, then we will try to answer as many questions as we can. And also, if you're on Twitter, you can hashtag, you can tweet about this webinar with the hashtag there that should be on your screen there, hashtag DW webinar. So let me introduce our presenter today. Our presenter is Ram Tanetti. Ram has been with Eaton now for over 7 years, and he is a product manager with a current focus on soft starters and drives. He has a master's degree in mechanical engineering as well as a master's in business administration, and he has also had many articles published in many national and international journals. And so we're here today to talk about soft starters, soft starts for motors, which, as we all know, if you use motors, you know that that's one of the issues, I guess, with starting any motor. Here we're talking about AC motors. We know that that there are some typical problems that that show up due to the physics of motors, inrush currents, forces on some of the parts, the shafts, the bearings, et cetera, et cetera. So we're here today to talk about how soft starters can basically help mitigate some of those problems. So we're going to talk about what are soft starters, what are the benefits of soft starters, and also some of the specifications you should know for choosing the correct soft starter for whatever your application happens to be. So, so I think I will step out of the way here and hand things over to Ram, and take it away, Ram.
Thanks, Miles. Good afternoon, everyone. Thanks for being with us today. Again, my name is Ram Tanetti, Product Manager in Eaton Corporation, the drives and soft starts. Today we are going to primarily focus on soft starters, and the agenda is going to look like this. We're going to talk about the fundamentals of a soft starter, reduced voltage starting mechanisms, inner workings of a soft starters as they are applied in pump, and also some of the severe duty applications out there, the value of using soft starts compared to some of the reduced voltage and across the line starting mechanisms, and the various specifications and applications that can be met using the soft starts. I got to preface by saying that every motor out there deserves a soft starter. And now, what is a soft starter? Soft starter is a solid state device which gradually ramps up the voltage and hence the torque associated with it. As a result of the gradual ramp up of the voltage, and as a result the torque associated with it, the mechanical and the electrodynamic stresses that are generated in the system are greatly reduced. And because of this reduction in the stresses in the system life increases and your maintenance cost decreases. So that is the biggest value prop of using a soft starter. Your system life increases and your maintenance costs go down quite a bit. And there are other peripheral advantages of using a soft starts, and we're going to see that in just a second here. And before we get there, let's step back and delve into some of the traditional reduced voltage soft starting mechanisms out there. The first is auto transformer, the second part winding, and Y delta. These are the most commonly used reduced voltage mechanisms that are out there today. And now what is an auto transformer starter? This device basically uses an auto transformer to reduce the current that is drawn from the power line. It may have multiple taps stepped through by multiple contactors to achieve the desired soft start. This device is somewhat unique in that because of the transformer action, the torque the motor develops is consistent with the line current levels, and it provides the best level of starting torque per starting amp, but at the cost of several current bumps at each contactor transition. So for the most part, you do get the reduced voltage play. However, it's not as smooth as a solid-state soft starter is going to give you. The second one in the series is the part winding starter. The part winding starter configuration has a stator with a couple of windings, 2 windings. And during the start phase, you initiate with 1 winding, you energize just 1 winding, and once you hit top of the ramp, both the windings are energized. So starter windings draw anywhere from 65 to 85% of lock rotor current, and each winding set carries 50% of load during run. And the biggest downside for this soft starting mechanism is similar to what we have seen prior, and that is the ramp up of the voltage is not smooth. Now let's study a little bit about the Y delta configuration, which is the most popular traditional reduced voltage mechanism that is out there. The Y delta starter is a multi-contactor device that connects the motor windings in a Y configuration and applies full voltage. By doing this, the line current being drawn is 58% of the normal locked rotor current. So the current that is drawn initially is significantly reduced by using this mechanism. And since the motor torque capability varies as the square of the current difference, the starting torque is reduced to 33% of the rated starting torque. So there is a heavy impact on how much initial torque that is generated, but it does reduce the inrush current that is hitting the system at the beginning of the start cycle. After a certain time delay, the motor windings are reconnected into a delta configuration and normal operation results. One downside of this is the reduction of torque during starting, and the second is the large current surge that occurs when the contactors switch from Y to delta configuration. Again, the smoothness of the transition is missing even in this reduced voltage mechanism. Let us now revisit what a soft starter is, keeping the reduced voltage mechanisms that are out there in perspective. Now, solid-state soft starter, again, is a solid-state device which gradually ramps up the voltage and, as a result, the torque associated with it. This gradual ramp-up of the voltage significantly reduces the mechanical and electrodynamic stresses that are generated in the system. And when these stresses are reduced, your system life increases and your maintenance cost decreases. And what enables the solid-state soft starters to do what it is doing? It uses solid-state switches called silicon-controlled rectifiers to ramp up the voltage. In the typical, this is a schematic of a typical modern soft starter which is out there. In these soft starters, SCRs are engaged during ramp-up and bypass contactors are pulled in after max speed is delivered. This helps to significantly reduce the heat that is generated in the system. Whenever a system is run with the SCRs, there is huge amount of heat that is generated, but soon after its purpose is done, the system can go into the run bypass contactor, which is a mechanical contactor, and that significantly reduces the heat that is generated in the system. This graph shows the voltage ramp as provided by soft starters. Soft starters provides the smoothest transition from initial voltage to full voltage, again as shown in this picture. It is a linear ramp going from an initial voltage setting as dictated by the customer to the full voltage over a period of the ramp time. This slide is by no means an artist's rendering, but it has two real-time graphs captured in it. The red line is the starting characteristic of a 300 horsepower motor when a cross-the-line contactor is used in the system. The blue graph right underneath that has the starting characteristic of a motor when soft starter is used. As you can see, the current draw reduces to 1500 amps from 2400 amps when soft starter is used. And now that is a reduction in current of about 38%. Typically, in a typical system, the motor during the initial phase draws about 6 to 8 times FLA for inrush current when a cross-the-line starter is used. That same requirement for inrush current drops down to 3 to 4 times FLA when a soft starter is used. Again, that is a reduction of about 40 to 50% of inrush current. Now let's come to the key question of why we need to upgrade to soft starters. The first four bullet points here are the ones we have discussed so far, and the first being by usage of a solid-state soft starter, you are reducing the amount of inrush that is drawn into the system, and as a result, the stress on the components are reduced. You're increasing the system uptime and system life, and you're reducing the amount of maintenance costs that go into the upkeep of the system. Another important facet of using a soft starter is the pump algorithm. In pump applications, there is a huge onset of water hammer which hits the system quite dramatically. And that water hammer can be significantly reduced and in majority of the cases eliminated by using the pump algorithm that is available in a typical soft starter. By usage of the bypass contactor, the heat buildup in enclosure is also dramatically reduced by using an integrated bypass soft starter. Finally, the reduction in the peak inrush current reduces the penalty that is levied by the utility companies. The utility dictates that a facility should not be pulling more than a certain amount of current. Otherwise, it penalizes the customers till the customer proves that their demand has come down. Soft starters ensures that this requirement is met. Now let's get into some of the applications where soft start can give effective solutions. The first is the pump application. The typical challenges that you find in pump application are with the high inrush currents causing the squirreling and snapping of belts, and the water hammer, which is a pretty common thing which happens in a pump application. Let's understand a little bit about the water hammer. In a typical pumping system, the pressure surges are caused by changes in flow because of pump starts, stops, opening, closing of valves, water column separation, and closure. Pressure surges lead to sudden changes in momentum of the water column. This momentum changes creates a shock wave that causes damage to the piping system. Such shock waves can damage the system and reduce the life. This can happen during ramp up or ramp down period of the pump. And this phenomena is called water hammer, and it causes significant damage to the check valve and surrounding pump system. Now, how can soft starter help in such situations? Soft starters come with a special pump algorithm which minimizes and in many cases eliminates the water hammer effect. This chart shows the difference in flow characteristics between across the line and pump control. As you can see, direct online, which is DOL, can quite rapidly increase the flow rate. DOL is, in other words, an across the line starting mechanism. Pump control, which is available in soft starter, follows a smooth S-curve for an extended time. This reduces sudden change in flow by controlling the acceleration torque of the pump motor and extending the time to produce 100% flow. There are no sudden changes in torque, and hence there is reduction in surge. Therefore, water hammer is reduced in the pumping system. Now let's look at the stopping characteristics in a pumping system. The DOL, which is direct online, reduces the flow quite rapidly. Pump control reduces sudden change in flow by controlling the deceleration of the pump motor and extending the time to get to a 0% flow, thus minimizing check valve slamming. To summarize, this slide compares flow versus time when different starting, stopping techniques are employed. The soft starter with pump control option produces the most desirable flow characteristic when starting and stopping centrifugal pump motors. There are no sudden peaks or breaks in flow that result in surges or hammering or slamming in the system. Now I'm going to allude to two videos which is going to capture whatever we have discussed in terms of usage of soft starts in pumping applications. The first video shows a check valve closure at the end of a pump cycle in a system without the soft starter. I'm going to run the picture one more time, or the video one more time. It's not as smooth as we want it to be, but what needs to be observed here is the intensity with which the check valve comes to rest at the end of a pumping cycle. I'm going to play it just one more time. Mind you, this video is a system at the end of a pumping cycle, how the system comes to rest when there is no soft starter. It's an across-the-line configuration. Now let's switch to the video 2, which shows you the exact configuration, but instead of an across-the-line starter, we are using a soft starter. Now you can see at the end of the pump cycle how the check valve comes to rest. I'm going to run that just one more time. You can see that the check valve movement from the top position to the rest position is much more smoother than what we have seen in the previous video. For this very reason, a lot of the pump customers are actively switching to soft starters. They have the municipalities, for example, who are the owners of a lot of pumps. They have put up specifications where beyond a certain horsepower, a soft starter needs to be definitely used. In Florida, for example, the municipalities dictate that anything over 50 horsepower needs to be a soft starter. And the reason why they did that is to eliminate the water hammer effect in the system and the resulting check valve slamming. Soft starters also pay rich dividends in severe duty applications. And these can include centrifuges, conveyors, aggregates, wherever there is high torque that needs to be required at the beginning of the cycle. In centrifuge application, as an example, soft starters can bring the system up to speed seamlessly and quickly compared to the wide delta systems out there. And also the peak inrush that is dictated by the soft starter is around roughly 3 to 3.5 times FLA, whereas the typical wide delta system draws a continuous 5 FLA for an extended period of time. Similarly, for starting an aggregate system where there is a high initial load and friction, kickstart featured in a soft starter can be used to overcome friction and also to provide the needed higher torque. After the motor gets going, it is then switched to a soft starter mode. The kickstart basically gives the initial oomph to get the motor going. Once the motor is going, then the configuration can switch into a soft starter mode. Such a feature is not available when you have a wide delta configuration or across the line configuration. We had numerous success stories with usage of soft starters and conversion of customers from traditional ways to soft starters, but this is one example I wanted to present. We had a pit mine customer, and they were troubled with the constant water hammer effect. They experienced check valve slamming continuously as soon as the pump turned off. They had extended amounts of downtime because of the maintenance which went into fixing the check valves at the end of the pump cycles. It was a pretty big motor application, 285 horsepower, and this customer was hesitant to use the soft starter first, so we kind of gave it to him at a discounted price just to make sure he understood the workings of the soft starter and he felt comfortable about using the soft starter. Once he used that in this particular situation where he was having longer pipes pumping water into the pit mine, he drastically reduced the amount of water hammer that was coming into the system. And since then, this pit mine customer has across the board converted all his traditional reduced voltage mechanisms into soft starters. And I think it was to the tune of about 100 soft starters or so is what he has implemented in his mining facility. The intention of this slide is to introduce you to the production features that are already embedded into soft starters. Because of this already embedded functionality, you can do away with some of the external devices used for the same purpose and thus reduce the cost. You got production features like phase control, phase monitoring, low voltage strips, high voltage strips, low current, high current, voltage imbalance, phase loss, SCR short fault, ground fault, temperature sense fault, among others. So again, the intention of the slide is that the modern day soft starters are not just coming with why they're used in the first place, which is to gradually ramp up the motor. They are coming up with a lot of additional monitoring and production functionality which can help the customer in doing away with some of the traditional ways of measuring and monitoring various things in the system. And that would tremendously reduce the cost of switching over from a traditional way of starting the motor to a soft starter. Now at this point, if a customer were convinced that they need to use soft starters, then the question arises if they can retrofit the existing starters with soft starters. The soft starters typically fit in any MCC or enclosure installation you have today. The enclosure doesn't need to be changed. You can use the same enclosure, and the built-in bypass contactor, which is integrated into the soft starter, minimizes any wiring and hence the labor associated with the electrician's time. And they can pretty much use all the same components that they're using today. So there is not much of additional work that is needed in removing the traditional starting mechanism they have in place and replacing that with a soft starter. And Eaton provides one of the smallest soft starters in the industry, thus making it very easy for the customers in retrofit applications. This slide here shows you the soft starters which can be used for various applications. We have offerings addressing the needs of various segments of the market and also the various applications within those marketplaces. The DS6, DS7, which is in the bottom left corner of this, addresses the needs of the OEM segment of the market. This is the segment of the market which may not be looking for any frills except for just soft starting the motor. And the DS6, DS7 just does that. At the middle end, in the commercial segment, you have the S611 addressing the needs of the commercial construction and also the high-end OEM marketplace. At the very top in the industrial space, we have the S801, S811 addressing the needs of that segment of the market. Between these products, we can go up to 1,000 amps, 690 volts, and up to 850 horsepower. An industrial user typically looks for the following in the soft starter. They're looking for a soft starter which is smaller in size, compact, but it has all the high-end feature set, including the bypass contactor, overload protection, adjustable ramp times, adjustable kickstart control, advanced monitoring and protection capability, communication capability, and such. And we do have, Eaton does provide soft starts for these industrial applications, and our product goes up to 1,000 amps, up to 690 volts, and at about 850 horsepower or so. Now, the commercial construction segment does ask for the high-end feature set. However, they need those at very economical cost points, and we have a product just for that. The S611 does deliver the functionality which the commercial construction and the high-end OEM market is looking for, and that includes the integrated bypass, integrated overload protection, the 120 volts control, doing away with any of the power supplies that are needed for any conversions, power monitoring, intuitive user interface, a user interface which can be used for real quick commissioning without needing a quick start guide, serviceability in the field. If after the soft starter has gone through its useful life of 15 to 20 years, you want to replace the important elements of a soft start like a control board. That can be done in the field. They need the pump control option for eliminating the water hammer, communication capability on board, and having this particular device in an enclosed control is also a key for this segment of the market. And the 611 product line which we have does serve very well in that marketplace, and it's available in NEMA 1, 12, 3R4, 4X enclosures. The product range for this particular product goes up to 414 amps from a current standpoint, 600 volts from a voltage standpoint, and up to 350 horsepower. This slide talks about some of the key specifications that are requested by the general customers out there. Generally, the customer is looking for a compact-sized soft starter with an integrated bypass, electronic overload protection, feature-rich products with extensive monitoring and protection capability, pump algorithm to minimize and eliminate water hammer, and for customers having 6-lead or 12-lead motors, they would like to have a soft start which can work inside the Delta configuration. That kind of a requirement typically comes from the elevator industry or from the HVAC marketplace. For more information about soft starts in general or about Eaton's soft starts in particular, you can get more information at eaton.com/soft starters. There are multiple tools that are available out there, including application notes, podcasts, FAQs, quick start guide, manuals, catalogs, and such. So I invite you to visit the website either to learn more about the soft starts. We have multiple application notes, including soft starts as they work with generator applications, as they work in centrifuge applications, or as they work in the pumping applications, and so on and so forth. Or you have podcasts and any other question you may have, chances are you will find the answer at the website. With that, I'll turn the floor over to you for any questions you may have.
Okay, well, thank you so much, Ram, for your for that presentation and for that info on soft starters. And I want to remind our audience here that we are taking questions, basically. So if you have any questions for Ram about any of the topics covered here, or maybe something that that Ram didn't cover that you'd still like to have an answer to, then please feel free to submit it there via the GoToWebinar question panel there. And I do have one question that came in earlier from Gagan. Hope I'm saying that correctly. And this was more of a question about, well, kind of a question about whether or not he really liked the video, those two videos that we showed. He was wondering if those will be part of the webinar presentation that we send out. And I don't know if I'm not sure right now if those will be or not, but we can find out and certainly follow up on that. So there was at least a thumbs up on the videos anyway. Let's see here what else we've got. How about well, here's one question about Ron, when you were talking about retrofitting. And maybe you covered some of this, maybe not. Maybe you can help me out here. But so what kinds of changes would people have to make to retrofit, basically to update to a soft starter? I mean, does it depend on the specific application, the motor size, et cetera, the control cabinet, whatever? Because it sounds like from your presentation, it sounds like you don't really have to do too much, but is that correct? Or?
Thanks for the great question, Miles. Really, whether you're converting from across the line or any other reduced voltage mechanism, the biggest element is just the size. You have the across the line starter in a cabinet. You just need to make sure that the soft starter can go within that space, and all you need to do is unhook the power wiring from the across the line, remove the across the line, drop in the soft starter, and plug the power wiring in. It's as simple as that, and then it should work. Okay.
All right. Here's some more questions coming in now. So let's see how many of these we can get to. Keep them coming. So here's a question from Andrew, and he asks about. He says he'd like to know, are the SSUL listed, and also something about cost guidelines, as well as a kind of dollar per horsepower rating. Are those are any of those kinds of data on perhaps Eaton's website, on that soft starter website that you mentioned at all? Or?
Absolutely. First of all, with regard to the UL, ours is a UL listed product, and so would be the competition's too. Unless you have a UL listing, you cannot sell within the U.S. primarily. And also, in addition to that, I got to add that some of the industries do need what is called a high fault combination ratings, and that can be unique to some of the products that are out there. That is not required by the UL, but some of the manufacturers go ahead and get the high fault combination rating. And what that means is, if you have a short circuit situation in an industry or in a factory, then the short circuit, the high fault rating, which is there with the soft start, gives the confidence to the customer that the soft start and the cabinet are not going to be compromised from a safety standpoint if that high fault rating is available. Some competitors do that, some do not. We do have the high fault ratings, and that's sometimes specified in the specs as well. We have up to 100 kA with fuses, 65 kA with the breakers, and again, that's an optional UL thing which people can pursue. And with regard to the cost information and cost per amp type of information, those are definitely available some of that information is in the catalog, and also there's a Bidman tool, and your local salesperson also would be able to help you with that information.
Okay. All right, good. I hope that answers your questions there, Andrew. Here's another question from Jamie. He wants to know how frequently can you do startings and stoppings on the motor with the ramp SSD?
Sure. The restriction is not really the soft starter. It would be the motor. If the motor can start and stop, let's say 10 times, soft start is going to support it. So the weak link in your system really is going to be your motor. Soft starter would support whatever motor can do. And typically an NEC rated motor supports about 2 to, let's say, 4 starts per hour, and a soft start can gladly support that. In fact, there were situations where we could go up to 10, 15, 20 starts per hour as needed by the application.
Okay. All right. Okay. Here's another question from James. He wants to know, do soft starters require any special fusing or protection?
Again, there got to be a line interruption mechanism ahead of the soft starter, whether it's a breaker or whether it's a fuse, and that is purely dictated by what kind of safety mechanism you want to have in the loop. It's no different than what you're already using today for your across the line or any other reduced voltage mechanism. There's nothing specific that is required for a soft starter.
Okay. All right. Good. The questions are queuing up here, so we'll see how many we can get to here. Next question here is from Spencer. He wants to know if you were to use a soft starter for a parallel motor starting application, would it be possible to have separate overload protection for each motor?
Yes, it is possible to have separate overload protection.
Okay. All right. All right, so here's a next question about payback. This is from Antonio. He wants to know what type or what would be a typical payback for a 250 horsepower motor. I don't know if that's if you can answer that specifically, or if this is a general kind of answer maybe you can give. Or.
Right. So typically what I say is when you use a soft starter, you're improving your motor life by a factor of 2. So you're doubling your motor life because you're reducing your inrush current by half, and hence your motor life increases. And the other elements that need to be considered in the equation are some of the other external devices you're replacing by using a soft starter, whether it's a phase monitor or whether it's an external overload or whether it's an external bypass or if it's an external current monitoring mechanism, power monitoring mechanism. All those can be replaced by using a soft starter. I have seen the payback to be anywhere from 1 year, the best case in 1 year type of a payback, and to about 2-3 years. So depending on what your system looks like, your payback can be really quick.
Okay.
And also in that vein, I got to also tell you that the various municipalities are now dictating that you need a soft starter because it's going to help eliminate the water hammer. And a lot of the utility companies are penalizing people if they go beyond a peak current draw. And all those requirements are met when you're using soft starter. And when those are accounted for, your benefits are really numerous.
Okay. All right, good. I hope that answers it. in a similar vein, I guess, here's a question from Beth. Beth wants to know, she says, is it economical for a retrofit for a motor that is 25 horsepower or less? Because she says, I have been told that it usually isn't.
Well, for Beth's question, what I would say is, I think I still have the control on this PowerPoint. I'm not sure if I do or not. But there was one slide where I showed the OEM products and and the commercial products and the industrial products. In that table, the OEM products are basically products without too many frills. It does the basic functionality of ramping up the motor, and those I have seen myself in my experience that from a cost standpoint, they're very close to having an across the line with a couple of monitors in the system. So those can be very economical.
Okay.
In essence, you can still do it below the 25 horsepower and still be inexpensive.
Okay. So it would still be worth it, basically. I think that's what she was kind of asking. Yeah.
That is correct. Okay.
All right. Okay. So here's I guess here's a slightly more technical type of question, but this is from Javad. And he says, great presentation, and his question is basically about the quality of the current drawn by the soft starter. He wants to know if are there any harmonics introduced into the network, or is there a integrated filter in the starter?
Jawad, that's a great question. Really good question, very good technical question. The soft starter basically is not changing the frequency of the signal itself. That is one. And also the SCRs, which are the solid-state switches, are only engaged during the ramp time. They're not engaged continuously. So there are literally no harmonics that are generated in the system. And I think where Jawad is coming from is he may have used drives in the past. And drives do generate harmonics, and that's because you are changing the frequency, and hence you're controlling the speed. And that's a good thing, whereas the downside is you generate the harmonics there. Whereas with the soft starter, you're not changing the frequency at all, and hence there is no harmonic generation.
Okay. All right. Good. Yeah. Good question there. Here's another somewhat technical question here too. This is from Anwar. He mentioned that it was mentioned in the presentation that soft starters can be equipped with communication software, and he says, is there software that Eaton provides, or presumably someone else, that can control the soft starters remotely? So web-based software to control the soft starters remotely.
Well, you do have various ways to do it. First is there is a web-based software which we have, which can be used for controlling the software. But if you want to do it remotely, the communications are available. The Modbus RTU is native. Ethernet-based protocols can also be gotten by using adapters, and those would very well help you in communicating with the soft starter remotely. Okay. So all the above means are available for remote communication to the soft starter.
Okay. All right. Good. So here's another question. This one might be a little specific, but we'll try it out and see. This is from Krishna, and he's asking, what is the starting voltage and startup time for a 690 volt and 690 horsepower water pump suggested? And then he also says, do you have any simulation software as well?
So this is a 690 volts, and did you say 690 horsepower? Both are 690?
Yeah. Okay. Yeah.
Okay.
Yeah, that's what it says.
All right. So typically, again, it's a pump application. And it's a variable torque application. Typically in variable torque applications, your normal ramp up is going to be about 15 seconds, and your initial voltage or initial torque can be set to about 40%. That should get you up to speed in about 15 seconds. And and is there any simulation software? There is one which is available. And we are trying to further refine that, but definitely if there is any specific information, we can help you out in figuring out what the initial parameters need to be.
Okay. All right. Let's see if we can get a few more questions in here. I think we're still doing okay on time here, but let's see how far we can go. Here's okay. So here's a pretty general question. I think this is from Usman. This one says, which one is better, a VFD, a variable frequency drive, or a soft starter?
Usman, great question.
Yeah.
Sure. Each one has its place. The contactor is at the bottom of the spectrum from a technology standpoint. The VFD is at the top of the spectrum from a technology and also from a functionality standpoint. Right in between is the soft starter. Each one has its place. So the VFD primarily is a good device to be used in variable torque applications, and that would be like fans, pumps, blowers. And in such situations, if your motor speed does not need to be at the full speed because there is not enough load, you can reduce the speed, and when you reduce the speed, you are having significant power savings.
Mm-hmm.
However, in situations like aggregate or whenever you're running pumps at full speeds, you can't afford a partial speed motor, then VFD is not adding any more value. That's where soft starts is going to come into picture. Soft starters fit that bill pretty well in that it can ramp up quite gradually to the full speed. That is one. It does not generate harmonics. And for the same horsepower, soft starts can be smaller and potentially less expensive. But again, if you're looking for a variable speed situation where you can really vary the speed, then drives is the way to go because the energy savings are significant. But if you're not going for variable speed, if you need to be at the top speed all the time, then soft starts can offer significant savings from a size and from a cost standpoint.
Okay. All right, and maybe this seems to kind of spiral or dovetail really nicely with that, with your answer to that question. But Conrad here has a question about. He says, "Can soft starters be used with variable speed motors?"
The limitation of soft starts is it can only take you to the full speed of the motor. So all it's doing is ramping up the voltage. So as long as you're going from, let's say you're starting from 20 volts and whatever the full voltage is, it's basically creating a smooth path to go from the 10 volts to, let's say, the 480 volts. Okay. And it takes you to the full voltage and to the full speed. So if the motor is, let's say, 900 RPM at 460 volts, soft starter is basically providing the 460 volts after a certain period of ramp up. So it's not controlling the speed at all. It's just controlling the voltage and ramping up the voltage. So the answer to Conrad's question is, if the motor is at the end of the day receiving the full voltage at the end of the ramp cycle, then soft start can do it.
Mm-hmm. Okay. All right. I think that probably answers it. Here's another question here. This one might be pretty straightforward. This is from Manoy or Manoj. I'm not sure if I'm saying that correctly or not. But anyway, I had a question about can you get a soft starter in a explosion-proof enclosure for classified applications?
Yes.
Yes.
The answer is yes, and we do that.
Okay. And also one more question from him then too. What is the price difference between a regular starter versus a soft starter?
Again, sure, and it depends on that chart which I referred to before for someone else's question. Depending on what you need, suppose you're not looking for too many frills, and you're using the basic soft starter, the price difference can be about 5 to 10%. Soft starter being higher compared to the across the line. But if you're looking at a soft starter with all the frills that are needed, then the cost is going to increase from there. So it depends on what you really need. But the low-end soft starter, which means the soft starter is still providing smooth ramp up, but without too many frills, the cost difference can be as less as 5%.
Okay. All right, that sounds good. Okay, let's see here. What about, here's a question from Michael. He says, what is the ambient operation or operating temperature for soft starters?
Typically, our soft starters can go from minus 40 degrees C to 50 degrees C, so they can operate in that environment without any problem.
Okay. All right. Let's see. Here's another one. Here's a question from Bubba. He says, if the motor has an integral brake, bringing single phase to the brake from the three-phase going to the motor, would it be better to come from the line or load side of the soft start to go to the brake? Sounds like a pretty specific type of question.
What is the inputs to the brake again? Did he say it's a single phase?
Let's see. Bringing a single phase to the brake from the three-phase, yeah. So there's three phases to the motor, but just bringing one single phase to the brake. Would it be better if he said to go from the line or the load side of the soft starter to the brake?
Right. So again, the soft starter gives three-phase input and three-phase output. It does not give a single phase out, or it cannot take a single phase in. So I need to, if Baba has my email and my phone number, he can call me and we can go into the details of the specific application.
Okay. And actually, that should be the slide that everyone sees now. So there's my contact information there, and there's also Ram's contact information too. You see his phone number and his email too. So any follow-ups there, you can certainly do it that way. So let's see. Here's another question here from let's see, who's this one from Brian, and he's working on, he says, a non-standard application. He's working on a autonomous lawnmower. That sounds interesting. So a little robotic lawnmower, I guess it's going to cut your lawn for you. But anyway, he was talking about part of the design upgrade is to add motor control for the mower deck and a second control for the weed trimmer motors. He said the previous design had a solid-state relay that controlled these motors, but the relays failed. So he wanted to add control to turn these motors on or off depending on where in the field they're cutting, what obstacles there might be there. He says the motors are 24-volt DC.
Yeah, so the soft starts are, so the question is, can soft starts be used there?
Yeah, I think so, yeah.
Okay, so typically the soft starts are AC devices, and they do not work with DC motors.
Okay. So is there any other method maybe, or?
Well, there are various contactor families that can be looked into, and there are some DC drives too, which can be used, which we don't necessarily offer, but DC drives can do the job as well. Okay.
All right. Okay, let's see here. I think we've got another question here. This is from, who is this from? From Ian, or Ian. He says, does the soft start, let's see, does the soft start motor application implement isolated control between control signal and solid state device, isolated by optocoupler? So he's looking at the isolation aspect of the signal there, it looks like.
There is definitely an auto coupler as part of the PCB of the soft starter. Yes.
There is. Okay.
Yes.
Okay. Good enough then. I think. Let's see. I think we've reached the end of the questions here, and I think we've reached pretty much the end of our time here as well. Once again, I'd like to thank Ram certainly for your time today and for your expertise and knowledge, and I'd like to thank all of you who came here as well and who submitted your questions. I hope we answered all your questions for you. And as I've said earlier, this webinar will be at our website on designworldonline.com, and also it will be you will be getting a copy of it in your email as well. We can kind of keep the conversation going either with myself or with Ram as well through our email addresses there, and through Eaton's website as well, which is in the presentation, and as well through Design World, through our website and through our engineeringexchange.com. So there's many different methods here that we can kind of keep the conversation going, I think that's it. I think that'll probably wrap it up then for us. So thanks again, Ram.
Thank you very much, Miles, and thank you very much, all of you, for spending your afternoon with me today.
Certainly. Okay. Thank you again, everyone, and have a pleasant day and a good weekend and a good holiday season as well.
Thank you. You too, Miles.
Okay. Take care, everybody.